Okay, this section is about something called polar coordinates. Okay, now we are familiar with rectangular coordinates. So they have coordinates x and y, where represents the x coordinate and y represents the y coordinate. Well, polar coordinates are a little bit different. We have two values, but they're called r and theta. Okay, r represents the radius, all right, from the origin, and theta represents the angle as measured from the x-axis. All right. Now, as an example, I want to plot this point, 4 pi thirds. Okay. Now, first let's consider the angle. So it's on pi over 3. All right, and that is along this line right here. Okay. And then the radius is 4. So we're going to count 4 from the origin, and that lands the point right there. Okay, so the coordinates of this point in polar coordinates is 4 pi thirds. So we consider the direction first and then the distance. Okay, the distance from the origin. All right. Okay, so let's plot this point, Q, which is r equals 6 and theta equals 240 degrees. All right, now 240 degrees, where is that? That's right here. So it's along this line, all right, in this direction, and it has a radius of 6. So counting from the origin, a radius of 6 will land us right there. Okay, and that's the coordinates of point Q. That's where Q is in polar coordinates. All right, let's plot this point. -5 3/4, 3 pi over 4. Now, considering the direction first, 3 pi over 4 is right here. But now r is -5, so instead of going along in the positive direction, we're going to go in the negative direction for a radius of 5. And that's going to land us right there for point R. Okay, so it's a negative distance in a direction of 3 pi over 4. Finally, let's plot this point. 8, -7 pi over 6. Now, considering direction first, if I'm going in the negative direction, 7 pi over 6 units, radians, and that lands us right along this line. Okay, that's -7 pi over 6. And then we're going 8 units from there in a positive direction. All right, so that means that that's going to land us right there. Okay. Okay, so these are how to plot points using polar coordinates. Okay, let's do this example. Write 2 or more possible names for this point, 4 and pi over 4. To plot this point, we're going to go here. It's on pi over 4, and it's a radius of 4 away. And now I want 2 different names for this, okay? Well, one of the ways we're going to get another name for this is to take an angle that is larger by 2 pi. Okay, what that is going to do for us is we're going to go all the way around 1. So we're going to add 2 pi to its existing direction, and then we're going to get right back to the same direction, right? So I'm going to take the same radius, okay, but I'm going to add 2 pi to pi over 4. All right, finding common denominators, that's going to be 8 pi over 4. And so another name for point A would be 9 pi over 4. Okay, there's another name. And we could actually add another 2 pi and another 2 pi and another 2 pi and continue to get more names for this particular point. Okay, but we're going to go get another name a slightly different way, and this time I'm going to use the form -r, and then I'm going to add pi to it. Okay, and that's actually going to get us to this direction right here by adding pi. Okay, so we're going to go in the opposite direction, and then we're going to take the negative direction from there. Okay, so this is going to be -4, and then pi over 4 plus pi. Okay, once again, common denominators will be 4 pi over 4, and then our name, another name for point A, using a negative radius would be -4 and 5 pi over 4. So this is 2 other names for point A. Let's get 2 more possible names for this point. 3, 150. Okay. First of all, plotting it, 150 corresponds to this right here, and then a radius of 3 is right there. So there's point B. Okay, we're going to kind of do the same thing that we did before. We're going to add 1 complete revolution, So we're going to add 360 degrees to the direction. All right, same radius, but we're going to just add 360 degrees. All right, so we're going around all the way to here. Okay, there's my 150 degrees, and then we're going to add 360 degrees to that. And that results in the name for this point of B 510 degrees. Okay, and once again, we could continue to generate more names by just adding 360 degrees to this. But we're going to go a slightly different way. And instead, I'm going to take a negative radius once again, but only add 180 degrees to it. Okay, so we're going to add 180 degrees to get this direction right here. Okay, and then adding, the radius is negative now, and then adding 150 and 180 gets us to negative 330 degrees. And that's another name for the point as well. All right, let's do this point. 5, negative 4 pi over 3. Okay, now to plot this point, we're going to go to negative 4 pi over 3. So we're going to go to pi and then another third of a pi, which is going to get us right there. And then a radius of 5 will get us right there. Okay, and we're going to apply, to get another name, we're going to apply the same strategy as before. We're just going to add 2 pi to this existing direction. Okay, and when I do that, it's going to be negative 4/3 pi plus 2 pi. Common denominators of 3, you get 6 pi over 3, and then adding them, we get 5, 2 pi over 3. And that's another possible name. Another way we can do this is by taking negative r and adding pi to the direction. So I'm just going to add pi to the direction. That gets us over here. Okay. Taking the negative radius, so we're going to go negative 5 and then negative 4 pi over 3 plus pi. Common denominators, and then doing a little math, and we get negative 5, negative pi over 3. And that's another name for this point. All right, now let's do some conversions between polar and rectangular. All right, so for example, let's just get a point on this circle. Let's just call it here. And it's going to have rectangular coordinates x, y, and it's going to have polar coordinates r, theta. Okay, and we want to convert from one to the other. First of all, we're going to go from polar to rectangular. Okay, and to do this, consider this, this would be the hypotenuse of a right triangle with one leg being x and the other leg being y, and then with angle theta. Okay, and so we can get this from SOHCAHTOA, right? So x would be cosine of theta is adjacent over hypotenuse, or x over r, multiplying both sides by r, and we get x equals r cosine theta. That comes from SOHCAHTOA. Same thing with the y. The sine of theta would be opposite over hypotenuse, okay? And then multiplying both sides by r, the hypotenuse, gets us to this, y equals r sine theta. So these are taking polar coordinates and converting them to rectangular, okay? And it really just comes from SOHCAHTOA. Okay, let's do this example. Let's convert this point with polar coordinates to rectangular coordinates. All right, so x is equal to r cosine theta, so 3 cosine pi over 4. And we want approximate answers with decimals this time. So the cosine of pi over 4 is root 2 over 2, which is 0.707. Multiply that by 3, and we get 2.12. To get the y coordinate, 3 times the sine of pi over 4. And that has the same sign. Sines and cosines are the same for pi over 4. So we get this, and it becomes, once again, 2.12. And so the rectangular coordinates that are equivalent to these polar coordinates are 2.12, 2.12. Okay, let's do this one. Negative 220 degrees. 2 rectangular coordinates. Now, just remember, let's get an eyeball for this. 120 degrees is kind of in quadrant 2. And then if we went negative 2 from that, that's going to get us into quadrant 4. Okay, so our point should be in quadrant 4. Let's keep that in mind as we do this. So x is going to be r cosine of 120. And if you punch out 120, the cosine of 120 in your calculator, it will be negative 0.5, which makes sense because cosines are negative in quadrant 2. And then multiplying that by negative 2 yields us an answer of positive 1. All right, now to get the y coordinate, we're going to take negative 2 times the sine of 120 Okay, the sine of 120 is root 3 over 2 or 0.866. Positive because we're in the second quadrant at 120 degrees. After multiplying that by negative 2, we get a value of negative 1.73. So the rectangular coordinates equivalent are 1, negative 1.73, which once again makes sense. If you think 120 is right there, if we go negative like that, we're going to have positive cosines and negative sines, or positive x coordinates and negative y coordinates, as we do. Okay, and if you think about that, the y coordinate has a greater absolute value than the x coordinate if we're down here, right? So this answer makes sense. All right, now let's convert from rectangular to polar. So for rectangular coordinates x, y, to get to r theta, we're going to consider x and y to be the legs of a right triangle with hypotenuse r. Okay, and then we can use the Pythagorean theorem to find the value of r. So leg x plus leg y squared, x squared plus y squared equals hypotenuse squared, and then take the square root to get r equals square root of x squared plus y squared. Okay, to find the angle theta, we're going to use a tangent function from SOHCAHTOA. Tangent is opposite over adjacent, or y over x. Okay, so let's use this to find two polar coordinate pairs for the point with rectangular coordinates negative 1, 1. Now, when you do this, you really have to pay attention to where you are. Negative 1, for a reason that will become apparent. Negative 1, 1 is in quadrant 2. So the point whose name we come up with has to be in quadrant 2. Okay? All right, so let's find the r first. So we're going to take r is equal to the square root of x squared plus y squared. X is negative 1, y is 1. Negative 1 squared is 1. 1 squared is 1. They sum to 2. And then the square root of that is positive or negative 1.41. And that's that positive or negative that we're going to have to pay attention to. Okay? As we'll see in a moment. Now, to find the direction, the tangent of theta is y over x, 1 over negative 1, which is negative 1. And then if you insert this into your calculator, it will give you a value of negative 45 degrees. Okay, now negative 45 degrees is in quadrant 4. We need a point in quadrant 2. So for that reason, we are going to take the negative radius here. So it gives us a direction of negative 45 degrees, and it gets us into quadrant 2. So a name for this point is negative 1.41, negative 45 degrees. Okay, that'll get us up here. Okay, to find, remember we want two coordinate pairs. So for that reason, I'm going to use this, negative r and then pi plus 180. Because if I add 180, okay, to negative pi over 4, that's going to get us up here. Okay, taking the negative of the radius, so that negative 1.41 is going to become positive 1.41, and then have a direction of 135 degrees. And so these are two possible names for this point that has rectangular coordinates negative 1, 1. All right, as a final example, let's find two polar coordinate pairs with rectangular coordinates 0, negative 2. Okay, so once again, we're going to find the r. Oh, by the way, where is that in here? It's right on the y-axis, right? Let's keep that in mind. Okay, 0, negative 2 is somewhere around there, say. Okay, to find the r, we're going to use the Pythagorean theorem. Okay, and it's 0 squared plus negative 2 squared. 0 squared is 0, negative 2 squared is 4. And so we get the root square root of 4, which is plus or minus 2. Okay. All right, now to find the direction, we're going to take tangent is y over x. And I get negative 2 over 0. Oh, problem. Negative 2 over 0 is undefined. Okay, so that is not going to yield an answer in our calculators. Okay, so we're going to have to do this a different way. But we're just going to have to pay attention to where this is. This is actually right here. 0, negative 2 is right here. What is the direction for that? Well, that's 3 pi over 2, right? And so we can use the theta is going to be 3 pi over 2, and then the r for that is going to be positive 2, okay? Or it could be negative pi halves. But if we take the direction as 3 pi over 2, then the r is positive, okay? And if we go negative pi over 2, the r is positive as well. because we're on the same, it's in the same direction right there. Or if we wanted to use a negative 2, we could go to positive pi over 2, and then r is negative 2. So another possible name could be this.